Hello, my name is Daniel Fradamico. I'm part of IST 220 Team 1, and today I'll be explaining how to do Lab 1, which is an introduction to Wireshark. Wireshark is an open source packet analyzer, meaning it captures packets off a physical or wireless network, and it provides special tools for organizations so that they can monitor traffic. Before beginning this lab, some of the objectives include explain the purpose of the Wireshark application, navigate the start page and main page of Wireshark, capture network traffic, and perform a network analysis by filtering the packets, analyzing suspect packets, preventing further intrusive traffic. So to begin this lab, we're going to start out by logging into your remote desktop connection Penn State servers, starting up the VMware, entering your user information, and once you're at this menu, go into your specific folder for your team. Once you're there, you're going to click the play button here. The progress is down here, it's completed, and click this button to launch the virtual machine console. Wait for it to boot up. Click inside the window, hit enter. So this is your virtual Linux desktop. To start the Wireshark application, go to Applications, Internet, and Wireshark here at the bottom. And enter password. You won't see the text, but it's being registered. Once the application starts, click OK to this message. So task 1 of this lab consists of navigating the start page, which is everything you see right here, and the main page of Wireshark. So to begin, this is the start page, and here are all your interfaces, such as your Ethernet controller or wireless device, whatever you use to connect to a network. Here's capture help. Here are your previously captured files. So before we begin an actual capture, I'm going to open up a sample PCAP file here that's been previously captured. So this section right here is called the packet list pane, and basically that contains a list of packets in the capture file not excluded by a filter. Basically it tells you the time, number of the packet, source, where it was originated, the destination IP, what kind of protocol, and a few information about it. Down here is called the packet details pane, and in that pane is a translation and analysis of most of the information in a packet. Basically it gives you more information than what was up here. And lastly, down here is the packet bytes pane, and in there is the raw data contained in a selected packet. It contains the raw hexadecimal data on the left and a translation of ASCII data on the right. So now that you know the basic definitions of the interface here, we're going to do a quick capture. So for interfaces, on this specific computer, ETH0 is the one you want to use. So click on that, and it should automatically start capturing on the network. Now the lab asks to capture for 1 minute, but for the sake of time, we're going to capture for a few seconds here. Okay, I think that's enough. So click this button here to stop the capture, and if you want to save it, you can go to File, Save As, browse for whatever name you want, capture, and click Save, and that'll save a PCAP file for you. So after you captured, you can go to Capture Options, and here are a few options that you can select depending on what you want to do with your capture file. For this lab, you probably want to utilize stop capture after a certain amount of minutes. The lab asks for 1 minute, so you would select this and hit start here. But since we already captured it, we'll forget about this for now. So after you captured traffic, we're going to move on to task 3, which is performing a network analysis. In this stage, you need to ask yourself who is sending the traffic, what kind of traffic, who is the target, and when did it start and when did it end. Most of that information you can find by just looking in this window over here, but if you want to filter it even more, there's a filter button right here where you can click on it, and you can filter by IP only, TCP only, or even just HTTP only. And then it'll, since we don't have enough traffic here to see it, it's all one protocol, it'll filter out the ones you don't want and leave what you just want. There's also another way to filter. You can type in your protocol here, or even an expression. Maybe you want something that was a certain time, maybe you want a number and a certain time. You can basically do a mix match of filtering depending on what you like. Lastly, you can also filter by right-clicking on a certain packet. So for example, if you wanted to filter just with the 10.0.0.0 source, you would right-click on this, apply as filter, selected, and it'll only select the packets that begin with this source, and the rest will disappear. Clicking clear will cancel all your filters. Another way you can also filter is by color coding your either protocols or source, so you can easily see without using options up here. You can easily see which protocols you're talking about because they're color coded depending on which color you use. There's a statistics menu here which includes summary, protocol hierarchy, conversation, endpoints, and I/O graphs. Let's go inside summary here. Basically, the summary contains the metadata about the capture: time, size, format, amount of packets, size of packets, etc. And that's all listed right here. The next one is protocol hierarchy, and that provides a short breakdown of what percentage of traffic belongs to what protocol. The next one is conversations, and that keeps track of the traffic based on the conversations between two hosts and what addresses they use. All listed here. The next one is endpoints. While conversations are pairs of hosts communicating, endpoints is a single side of a conversation. It basically shows the traffic in relation to a single host. And the last one is I/O graphs, and it allows you to make graphs of the capture based on the display filters that you choose using either method to filter packets. There's a nice tool up here called the Find a Packet. Basically, you can click on that, type in a protocol or hex value or string, and it'll find it for you in here. For some reason this isn't working, but this is your protocol and it'll list all your IGMP protocols here. Wireshark also has a neat tool called ACL, or Access Control List Rules. Basically, that's able to filter out any offensive packets that appear in your capture here that you don't want to see and just completely remove from your capture file. So let's say this last packet here is considered offensive and I don't want to see it anymore. So you go up to Tools up here and go to Firewall ACL Rules. And here you can choose the type of firewall you wish to write a rule for in here. And you can also choose the quality of the offensive packet to deny, such as a port or address. So that is basically a quick walkthrough of Lab 1, and the questions include starting a 1-minute capture, and it asks you which address is sending the most traffic, and that can be found right here, 60 bytes on wire, and you can look through each packet. This one has 54, this one has 60 again, and 54. So basically your answer would be 1 and 3, since they're both 60 bytes, they're sending the most traffic. And the other questions include what sort of traffic is using the most network resources, and then you have to filter out the address that is sending the most traffic, basically the same way that was explained earlier. You can filter here or here, and you can either type in the source filtering, or you can even type in how many bytes it used, because you know that this is using the most, and it'll filter that. Then you can also filter which conversation is showing the most traffic. And lastly, it asks you to write an ACL rule for one of the addresses in the traffic on a Cisco firewall, which can be found again by clicking on a packet, going to Tools, and ACL Rules. So this concludes the demonstration for Lab 1. I hope it was very informative. Thanks for watching.